Find the partial fraction decomposition of the rational function x minus 3 over x cubed plus 3x. In order to find the partial fraction decomposition, we need the denominator to be the product of linear or irreducible quadratic factors only. The fundamental theorem of algebra states that we can always factor a polynomial of degree 3 or more into linear or quadratic factors. And so first, we would factor the denominator x cubed plus 3x. There is a common factor of x, so we would factor out x. We end up with x squared plus 3. X squared plus 3 will never be 0, and so x squared plus 3 is what we call an irreducible quadratic factor. The given rational expression is therefore x minus 3 over x times x squared plus 3. This can be rewritten in the partial fraction decomposite form as a over x plus, for the second simpler fraction, the denominator is x squared plus 3, which is an irreducible quadratic, so the numerator has to be a linear term. We already used the letter a, so this time we would use bx plus c. Bx plus c is linear. This expression, the sum of the two similar expressions have to be the same as the given expression x minus 3 over x cubed plus 3x. To find a, b, and c, we would first need to find the least common denominator of the right-hand side, which is x times x squared plus 3. To combine them, we would first need to multiply a over x with x squared plus 3, both top and bottom. And we would multiply the second fraction with x, both top and bottom. That's the golden rule. Simplifying this, we have ax squared plus 3 times a times 3, plus bx times x is bx squared, and c times x is cx, and all of these over the same common denominator, which is x times x squared plus 3. And again, this needs to be the same as the given rational expression x minus 3 over x cubed plus 3x. For these two expressions to be the same, equal, the denominator must be the same, and they are the same. The numerator must be the same as well, so we must have 1x minus 3 on the left-hand side equals, and then we group the like terms, ax squared plus bx squared plus cx plus 3a. There is a terms of x on the left-hand side, but there's no x squared on the left-hand side, so we go ahead and add 0x squared. 0x squared is no x squared. Comparing the coefficient on the left and on the right-hand side of this equation, we must have 0 equals a plus b, where the coefficient of the x squared terms on the right-hand side are both a and b. It is better to factor out x squared before doing this, but we can clearly see that the coefficient of x squared on the left-hand side is 0, and the coefficient of x squared on the right-hand side is again both a and b, a plus b. Similarly, the coefficient of x on the left-hand side is 1, and the coefficient of x on the right-hand side is c. It remains that negative 3 equals 3a. From this system of equation, we see that c equals 1. Also, a equals negative 3 over 3, which is negative 1. But if a is negative 1, then b equals negative a from the first equation. A is already negative 1, so negative a is positive 1. And so, we have the coefficient we're looking for. we can rewrite the given rational expression x minus 3 over x cubed plus 3x as, we set it up so that a is the coefficient on top of x, and we found that a is negative 1. So the first simpler expression is negative 1 over x, plus for the second simpler rational expression, the denominator that we set it up is x squared plus 3, and the numerator is bx plus c, but we found that b equals 1, so we have 1x plus c, c is 1. And so this is negative 1 over x plus 1 over x squared plus 3.